So we'll see the asynchronous counter. So here you will be having like a 2-bit up counter, 3-bit up counter, 4-bit up counter. So 2-bit, it means that how many transition it has to count? 2-bit synchronous counter. So I will be using the D flop here. If it is a 2-bit, how many bits it has to count? If it is a 2-bit, how many flops you need? How many transition it has to count?
4.
Sorry, if it is a 2-bit, how many transition? If it is a 2-bit, it has to count like a 4. 0, 1, 2, 3, 4. Again, it is like a, if it is up counter, here I am taking the up counter. 2-bit up counter. 2-bit up counter, it means that it has to start from 0, 2, 3. Again, it has to count from 0, 1, 2, 3. It has to count. So since it is a 2-bit up counter, you need a 2 number of flops. Here I am using the D flop. You can use the JK, T, whatever it is, but since we will be using the D flop, so I will be using the D flop. Okay. This is a D flop. Yeah. Any doubts? This is D flop. Q will be output and there will be a Q bar. And you will be, here I am taking the clock signal. This will be the clock signal. This is a flop 1. Consider this is a D1, Q1 and Q1 bar. So you will be having another flop. This will be D2, Q2. This will be the clock signal. This will be Q2 bar. So here for the D1, you have to provide the input. So the input will be given from Q1 bar. This Q1 bar otherwise take the this will be the clock signal for the flop 2. This is flop 2. For the D2, you have to give the, this is the output. This is the feedback signal. So here you can see that for the flop 1, you are providing the clock signal. But for the flop 2, the output of the Q1, nothing but the output of the F1, flop 1 is the clock signal. Suppose here you are considering that, we'll see how it works. So this is the clock signal we are taking. This is a clock signal, okay? So here I am taking the negate. What is the falling edge? What does it mean, falling edge of the clock?
When the clock signal goes from positive to negative,
Yeah.
means from high
The
to low.
clock signal having a transition from high to low or the positive to negative. So that's why we used to call like a falling edge, negative edge and all. This is the clock. So initially the flops will be having 0 0. So this will be the Q1 and this will be the Q2. Initially you will clear the signal and here you will be having the clear signal or the reset. Initially it will be 0 0. So this input is 1. Now what happens if the first falling edge of the clock, what is the input? D is 1. So what will be the output here? At the first falling edge of the clock, the input is 1. So what will be the output of the Q1? Q1 will be 1. Why? Because
One.
input is 1, output will be 1. So till the next falling edge of the clock, it will be 1. So here at the next falling edge of the clock, what will be the input at the D1?
0.
0. Why? Because it is 1. It means that it will be 0 and it will feed the input as 0. So at the next cycle here, the input will be 0, the output will be 0. So till next falling edge of the clock, the output will be 0. At the third next clock pulse, the input will be 1. Why? Because Q bar will be 1. That Q bar will be connected to D1. So the input will be 1. So input is 1. The output will be 1. Till next falling edge of the clock, the output will be 1. So nothing but what it is doing, it is continuously toggling, right? Yes or no?
Yes.
So here first initially Q is, I, instead of this I'll take Q bar also. So you will get it. God. So here I'll take Q1 bar. So it will be easy for you guys to understand. So if it is 0, it means that it will be 1. So Here it will be 0, right? Q1 bar will be 0. That it has provided to the till next, it will be 1. This is the input. 1 is the input. So what you will get? 1 is the input. So you will get Q bar will be 0. So for the next signal, this will be 0. For the next in signal, it will be the input, right? So Q bar will be the Q will be the output. Just don't confuse. I'll just do this one. Okay, take. Initially, Q1 will be 0. So Q1 will be 0. What about the Q1 bar? Q1 bar will be high, right? Q1 bar will be height. Sorry, high. So once it is high, so once you apply the input, here it is 1, so output will be 1. So output will be 1 till next rising edge of the, falling edge of the clock. So Q1 is 1, Q bar will be 0. So Q bar will be 0. So for the next falling edge of the clock, what is the D input? D is connected to Q bar. Q bar is 0 here. So the Q will be 0 till next rise falling edge of the clock. So it is 0. It means that Q bar will be 1. Q bar will be 1 till next falling edge of the clock. Once the next falling edge of the clock rises, D input is connected to Q1 bar. Q1 bar is high. So the output follows the input. Q1 will be high till next falling edge of the clock. Q1 will be high, Q bar will be low till next falling edge of the clock. So once it next falling edge of the clock triggers, it will connect it to the Q1 bar. So Q1 bar will be 0. So the output will be 0. Q1 bar is 0. So Q1 is 0. Q1 bar will be high. So for the next falling edge of the clock, the input is Q1 bar. The Q1 bar is high, right? So the Q1 for the next will be high because it is feedback loop, right? So you can see that it is continuously toggling between 0, 1, 0, 1, 0, 1, 0, 1. So it is continuously toggling 0, 1, 0, 1. Any doubt here? Any doubt? Any doubt how we got the toggling? Guys, any doubt?
No, ma'am.
Okay. For the Q2, here you can see that Q1 is a clock signal. Q1 is a clock signal for Q2. For Q2, Q1 is a clock signal. Here you can see that. So it will be 1. Initially it is 0. So till Next rising, nothing but till the clock signal enables, it will be 0. So the clock signal is Q1 here. So it will be 0. Once the clock pulses hits, nothing but the clock edges arrives. So you will get the Q2. What is the D2? D2 is high. So till next falling edge of the clock, the output will be high. The output is high till next falling edge of the clock. So for the next falling edge, the D2 is connected to Q2 bar. It is 1, so it will be 0. So for the next falling edge of the clock, the input will be 0. Input is 0, output will be 0. So till next falling edge of the clock, output will be 0. So this is 0. It means that Q2 bar will be 1. So for the next falling edge of the clock, it is giving feedback loop 1. It will be giving as an input. If input is 1, the output will be 1. So output will be 1 till next falling edge of the clock. It is continuously toggling. So this will be, we are taking the input as, sorry, output as Q1, Q2, right? We are taking as Q2, Q1. So here you can see that first clock cycle, second, third, fourth, fifth, sixth, seven, 8. So here initially it will be 0, 0, 0, 1. This will be 1, 0, 1, 1, and this is 0, 0. It is 0, 0, 0, 1, 1, 0. Again it will be 0, 0. Here you can see that at the first clock pulse it is 0, 0. Second clock pulse it is 0, 1. Second, third, this is 1, 0, 1, 0. Fourth, it will be 1, 1. Fifth, again it is 0, 0. This is 1, right? 0, 1, 0, 1. At seventh, sorry, 0, 0, 0, 1. This will be 1, 0, and this is 1, 1. 1, 0, and 1, 1. You can see that this is counting as 0, 1, 2. This will be 3. Again, it is counting 0, 1, 2, 3. So it is counting from 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So this is a 2-bit up counter. Where you can see this 2-bit up counter, application was counting purpose, and here you can see that frequency is dividing here. Here this will be the, suppose how it will be working as a frequency divider. How it will be as a frequency divider circuit. What is frequency divider? Here if you see that this is a 1 clock pulse, this is like a T, and here it is taking 2 clock cycles. To get 1 clock period at the output, you are taking 2 clock cycles. Nothing but it is a 2T, right? 2T is nothing but frequency is dividing by 2. What is frequency? 1 by time period, right? So it will be dividing by frequency. So here nothing but it is taking a 2 clock periods. Here you can see that this is taking 2t. Suppose if it is this will be the 1t, right? To get a 1 clock cycle, it is taking a 2 clock periods. So that's what it is 2t. So if it is taking a 2 time period, what is the relationship between the time and the frequency? It is reciprocal, right? So if it is taking a 2t means it will be having a f by. So that's why this will be using in the 2-bit, sorry, frequency divider circuit. This is a 1 frequency divider by circuit. For PD guys, it is very, very important. This circuit is very, very important. This is frequency divided by 2 circuit. Any doubt? For the 2-bit down counter, how will you take it? For a 2-bit down counter, how will you do it? Guys, for a 2-bit down counter, how will you do it? Any doubts in the up counter? Am I audible? Are you
Yes,
guys
ma'am.
there? Yeah. Any doubt in the up counter?
No.
Any doubt in the up counter? Guys, any doubt?
No doubt.
Okay. You got the up counter, right? So my question is like, how will you do the down counter?
Positive clock.
Okay. Can you please do it and let me know? Post it in the group. Design a 2-bit down counter. Are you guys doing? Guys, are you guys doing it or not? Please let me know if you're not able to do it at least. Or if you guys need a time, then take it as an assignment and I'll proceed further. Are you guys doing the down counter?
We will do it as assignment, ma'am.
Okay. And also do it 3-bit up counter as an assignment. Next, we'll go to the synchronous up counter. What is the synchronous up counter? What is the synchronous up counter?
Same clock applied to flip-flop.
Sorry? Yeah, tell me. You are right. Tell me. Guys,
Same clock applied to three flip-flops.
yeah, the clock will be applied for the all the flop at a time. So how will you do it? How will you do it? For the up counter, there are a step. First, if it is a 2-bit, you have to decide how many flops are required. If it is a 2-bit up counter, how many flops are required? This will be
2.
2 synchronous. Up counter. So for the 2-bit synchronous up counter, in the first, you need to decide how many flops are required. So you need the number of flops. Here we are using 2-bit, so we need the 2 number of flops. Next, for that we have to draw the excitation table and the state diagram and get the equation. So after that you have to design it. In the asynchronous, directly we are giving the inputs for the flops, but here we need to give the inputs as per the equation, because we are giving the clock pulse at a time, right? So first step is to decide the how many flops are required. Next, to get the excitation table. So what does meaning of excitation table? What is the meaning of excitation table?
It generally describes the inputs given to the flip-flop with respect to the present state and next state.
Yeah. With respect to the present state and the next state, it will provide the inputs. So here we have to draw the state diagram and the excitation table. And from the excitation table, you need to get the simplified equation. So with respect to that equation, you have to provide the inputs. So here we'll get the state diagram. What is the state diagram? What does the state diagram represents? The state diagram represents the present state and the next state. So here 2-bit synchronous up counter will be having how many states? 2-bit up counter having how many states? It will be having 4 states. Nothing but yes not is nothing but 0 0. So after the yes not, it has to count for S1. Nothing but 0 1. So after 0 it has to count 1. So after 1 it has to count for 2. Nothing but this will be S2. This will be 1 0. So after 1 0 it has to count for S3 is nothing but 1 1. So after 1 1 again it has to count 0 0. So here the present state is 0 0, next state is 0 1. When the present state is 0 1, next state is 1 0. When the present state is 1 0, next state will be 1 1. So just for testing, you can take D1, Qn and Qn plus 1. Nothing but these things. So here we are taking D1 and T naught. Here you take Q1 and Q1 plus. Okay. Don't take it. Q1 plus. So this you can take it as 0, 0, 0, 1, 1, 0, 1, 1. These are the present state, right? Sorry. This will be Q naught. This will be Q1 plus and Q naught plus. With respect to that, you need to get the D1 and D naught. So if present state is 0, 0, what will be the next state? This will be the present state. And this is next state. So if present state is 0, 0, what will be the next state?
0,
1, 0, 1. If present state is 0, 0, 1, what will be the next state? If
1, 0.
1, 0. If present state is 1, 0, what will be the next state? If present state is If present state is 1, 0, what will be the next state?
1, 1.
What about next? If present state is 1, 1, what will be the next state?
0, 0.
0, 0. So here you have the Q1, Q1 plus. With respect to that, you need to get the D1. If Q, so with respect to Q naught and the Q naught plus, you need to get the D2. If present state is 0, next state is 0, what might be the input of D1?
0.
0, right? If present state is 0, if next state is 1, what will be the output?
0.
Sorry? Yeah. If present state is 0, next state is 1, what might be the input of D?
1, 1.
So 1. Why? Whatever you have the next state, that will be the input of your D1. If it is 0, 1, sorry, 1 is the present state, next state is the 1. So what will be the input of the D1?
1.
1. If present state is 1, the next state is 0, the output will be nothing but the input of the D1 will be 0. Why? Because the input of the D1, whatever you will get it on the next state. Similarly, for the D0, the present state is 0, the next state is 1. So the input of the D0 will be 1. If the present state is 1, the next state will be 0. The input of the D0 will be 0. If the present state is 0, the next state is 1. It will be 1. If the present state is 1, the next state will be 0. The D0 will be 0. So now you have to get the expression for D0 and the D1. Why? Because you have the circuit here. D1 and the D0. But you don't know what is the input. Suppose this is the D1 and this will be D0. So you don't know what is the equation at the D1 and the D0. What you have to connect. So for that you have to get the equation. This is the clock. So for this one, this will be Q1. This will be Q0. So for that, you have to get the expression for Q1 and the, sorry, D1 and the D naught. How will you get the expression? Which key map you need? Which key map you need? Which key map you need? How many K cells are required? Guys, how many K cells are required?
2:2.
So this will be Q1 and this will be Q0. This is for D1. This will be 0, 1, 0, 1. This is for D0. This will be Q1. This will be Q0. This will be D0. This will be 0, 1, 2, 3. 0, 1, 2, 3. 0, 1. So this will be 0, 0, 0, 1, 1, 0, 1, 1. So with respect to that, where it is high, 1 and the 2 are at a high. 1 for the D1, 1 and 2, these are at a high. These all will be 0, 0. So present state you need to full. Why? Because with respect to next state only we are getting the equation. So here you can see that it is 0, 2, it will be high. 0, 2, it will be high. 1 and 3 will be 0, 0. So here for the D1, what is the group you can make? This will be single group. So you can make it here. So with respect to this, what is the equation? With respect to this, Q1 will be 1, Q0 will be 0. Nothing but Q1, Q0 bar plus this will be Q1 bar, Q0. Q1 bar, Q0. Nothing but this will be Q1 XOR with Q0. Whereas D0, you will get the expression as this will be like one group, right? This will be 0, 1. So Q1 will be Q1 will be Q1 will be
0.
nothing but it will be not considered. So it will be D0 will be Q0 bar. So Q0 bar. D0 will be the Q0 bar, which is connected to here. This will be output of Q0. For the D1, what is the input? It is Q1 XOR with Q0. So it is Q1 XOR with Q0. Q1 XOR with Q0. This will be Q1 bar. This is the circuit for the 2-bit synchronous up counter. Any doubt in the counters, where's the synchronous and the asynchronous? Which is easier, synchronous up counter or the asynchronous up counter? Guys, speak up.
Synchronous.
Synchronous up counter is easier. Hmm? Am I audible?
Yes, ma'am, you are audible.
Yeah. Tell me. Any doubt in the counters? How will you do the down counter? How will you do the down counter? Guys, how will you do the down counter? How will you design the down counter?
Take one as a
Hmm? Yes.
taking one as the first input.
Hmm? What will be the state diagram for the synchronous down counter? What will be the state diagram? Guys, what will be the state diagram for the down counter? Are you guys there?
Taking Q and Q0 is 1.
Hmm? State diagram. Leave about the excitation table. State diagram for the down counters. Able to see you guys. Yeah. What will be the state diagram? Can you guys just write down the state diagram for the down counter and post it in the group? I will be waiting for your state diagrams everywhere. Draw the state diagram for the 2-bit down counter and post it in the group. I will be waiting to see your down only state diagram. Guys, I'm waiting. Only the state diagram. Are you guys there? Guys, okay. I think someone has posted 113210. Yes. Who has posted this one? Who is it? 407.
Meaning,
Dishant, you?
yes.
It's Ramadin,
Yeah.
madam.
What about others? Asma, Srujan, Shiva? Ganesh. Ganesh, is it the first class for you?
Yes, ma'am. Yes, ma'am.
Okay. Guys, state diagram. Srijan, Asma, Shivram, are you guys there? Two-bit down counter. Zero zero 1 1 1 0 0 1 0 1. For the 2-bit down counter, first it will be counting from 0 0 or 1 1. What will be the present state for the down counter?
0 0.
0 0. Okay, two more people, only those two guys have posted, right? What about others? For the 3-bit, it will be like here. This will be the up counter. For the down counter, it is like 3 2 1 0. This will be the down counter. Up counter is 0 1 2 3 0. For the down counter, it will be 0 3 2 1 0. This will be the down counter. With respect to that, take the present state and the next state and get the equation. Any doubt in this?
No, ma'am.